Greetings and welcome, friend. Yeah, you know what? You're welcome. Because you should be thanking me already for this amazing video that you're now watching on YouTube, perhaps. Yeah, you're welcome. Yes, consider yourself welcomed. I've invited you to the table in the discussion of solving inequalities with addition or subtraction. Here we go, section 2.2. Here's a little fact for you, friends. Equivalent inequalities are inequalities that have the same solutions. All right, okay. Okay. An example of those would be, for instance, x is greater than 2 and x plus 1 is greater than 3. Both of these inequalities, they're different, but they would have exactly the same solution set. I'm going to slow your horses, maybe, if that's a thing, before we start solving this. But I just want to point out these ones have the same solution. So like 3 is a solution here. Would 3 be a solution here? 3 plus 1 is 4. 4 is greater than 3. Yeah. 5 is a solution here. 5 is bigger than 2. 5 plus 1 is 6, which is bigger than 3. And let's actually try a not solution. How about 0? Is 0 bigger than 2? No. How about 0 plus 1 is 1? Is that bigger than 3? Also no. Okay, so far it seems to check out. Equivalent inequalities, same solutions. Here's this, the addition property of inequality. We already know the addition property of equality. This one is not much different. In fact, I would say it's nearly identical. It says adding the same number to each side of an inequality produces an equivalent inequality. So that's why we had to throw that little terminology up there so you would know what we're talking about. It will have the same solutions if I add the same number to both sides of an inequality. Okay, so here we go. So with numbers, notice this is kind of weird, but negative 3 is less than 2 is true. If I add 4 to both sides, negative 3 plus 4 is 1, 2 plus 4 is 6. Is 1 less than 6? Yes, still true. All right, that's not the most persuasive thing, but I just wanted to point out that it works. Or how about this? Negative 3 is greater than or equal to negative 10. Is that true? Yeah, negative 3, I would rather owe someone $3 than $10. So yeah, that's the greater situation for me. So yes, negative 10 is less than negative 3. If I add 3 to both sides, is 0 bigger than or equal to negative 7? Yeah, still true. Still true. Here's the algebra, okay? If A is greater than B, then I can add C to both sides, and it will still be greater. Okay? We compared this to like a balance beam back when we had the equality situation, right? If I had like little things going on over here and here, where with like the balance beam, I need one more thing here. Pretend that's balanced. If I had two things that were balanced and I added something to both sides, let's say I add, I don't know, a little house piece. And if these were already balanced, and if I add two of the same thing to both sides, they will still be balanced on a little balance scale, right? Now, similar idea, if I have an imbalanced scale, one side is heavier than the other, okay? This side's heavier because it's down. And I've got, let's see, I guess I should draw my pictures here. I'll have like a little circle, triangle here, and over here I'll have one of the house pieces. Okay, so it's imbalanced. Oh, we got some garbage pickup. Actually, wow, that's nice. It's not picking up in my mic. I'm pumped about that. So this is imbalanced. If I add the same thing, here a green square to both sides, it's not going to change the imbalance. This side is still heavier, right? Like by adding the same thing to both sides, it will still be the heavier side. Okay, actually, I'll leave that right there. That looks good just like that. The same thing works if I have greater than or equal to signs, less than signs, or less than or equal to signs. I can add something to both sides, and if it's the same The relationship is still the same. Wow, there we go. Guys, feel free to auto-tune that song I just sang for you. I do expect royalties, however. So, here is, actually, yeah, some of you guys might appreciate this. Here's a diagram. Okay, here we go. Number line diagram. Don't write this down. If I have 2 points, A and B, and A is less than B on the number line, and then I move A by C units, and I move B by C units, I move them the same distance, and so these will still be less than each other, just like the less than was here before. You buy that? Does that seem reasonable? Does that seem like a legitimate, sufficient explanation for you, I hope? Let's see. Let's actually put this to work, friends, because this is what we came to do. I came to solve inequalities and chew bubblegum, and I'm all out of bubblegum. All right. X minus 6 is greater than or equal to negative 10. I want to solve this. That means I want to get the variable by itself. What is the inverse of subtracting 6? Add 6. We're really going to do this and just pretend this is an equal sign the whole time. Same steps, friends. Same steps. The 6's would cancel out. I'd have x is greater than or equal. Let's see, negative 10 and 6. Signs are different. Subtract the numbers. 10 minus 6 is 4. And who was more influential? The 10. 10 is more influential. Negative. So x is greater than or equal to negative 4. It is solved. They also asked me to graph. Let's see. Should I pull up my... Here we go. I'll draw a nice number line here. That looks good enough. Let's see. Look at this beautiful number line. Gorgeous number line right there. Yeah. I'll throw a 0 here, and negative 4 seems like a point of interest to us. And let's graph our solution set. Here, get that dark green going. Let's see, greater than or equal. Open circle or closed circle? Closed, because it's got the equal part, so I shade it in. And let's see, greater than, the positive numbers are to the right, the negative numbers are to the left. Greater than negative 4 would be towards the positive numbers. Let's see. So I would shade it that way, right? There we go. Look at that shading. There we go. And what I'm suggesting is this. I could do a quick little fake check. All right. I don't want to check infinitely many points into the original equation, but you could check 0. 0 is the easiest number to do checks with. It's in the shaded region. Let's just see if that happens. If I plug in 0 for x, is 0 minus 6 greater than or equal to negative 10? 0 minus 6 is still negative 6. Is that greater than or equal to negative 10? Yeah, I'd rather owe someone $6 than $10. Yes, I agree. So if you wanted to do a check to see if you shaded in the correct direction, you could just pick any number within the shaded region. You could have picked 1 or 20 or a Google or pi, square root of 7. All of these great numbers, you could have tried them out. But yeah. So that's not bad at all, right? I mean, we did the same thing we would have done if it was an equation. So not too shabby, I don't think. Let's try rapid fire. We'll try to do these ones. Okay, here we go. B minus 2 is greater than negative 9. I want to solve for B. What do I do to both sides? Add 2, add 2. How about over here? What do I do to both sides? Add 3, both sides underneath those like terms. Whoa, this one's backwards. A quarter is greater than y minus a quarter. How do I get y by itself? Add 1/4 to both sides. I like it. Okay, let's see what the results are. The results are in here. The negative 2 and the positive 2 cancel out. I get B is this now suddenly going to be like an equal sign? Is this going to be a less than sign? No, it is still greater than. I can add the same thing to both sides. It will still be a greater than symbol. Negative 9 plus 2 is negative 7. Answered. Bam. Over here, M, the 3's cancel out, less than or equal, still less than or equal. Adding the same thing to both sides isn't going to change that. 5 plus 3 is ocho, like socho. And let's see over here, add a quarter to both sides. Ooh, a quarter plus a quarter is 2 quarters. We'll be able to reduce that. These ones canceled out. I get y by itself. It's still a greater than sign. Let's reduce that. 2/4. What number goes into both of those? Yeah, 2. 2 goes into 2 once and into 4 twice. So I'll get 1/2 is greater than y. And let's just flip this around while we're at it. I'm going to write that as y is less than 1/2. Notice when I do the flip, what happened? The inequality flipped as well. Flip it. Okay, let's get some number lines going here. Watch this. This is going to be great. I'm going to just like draw 3 number lines at once. Guys, I think I'm going to set the Guinness Book of World Records for most number lines drawn. Whoa, you saw that? We got it on video. Yeah, it recorded, friends. Man, I'm pumped. You just saw that? I just drew those number lines so swift. Bam, 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 bam. Let's see. So for number lines, you got to have 0. Negative 7 seems to be the point of interest. That's going to be less than 0. Here, I'll put 0 over here, maybe 8 over here. That sounds good. Over here, let's do 0 and 1/2. Tell you what, for a fraction, watch this trick. I'm going to put a 1 here and then halfway in between. That looks like a 1/2. Let's giraffe it. B is greater than negative 7. Open circle. Greater than, shaded towards the positives. Guys, you are going to be so good at this. I'm pumped. We're going to knock this out of the park. We should do like a mini quiz tomorrow because these are going to be so great. Greater than or M is greater than or equal to 8. Sorry, less than. Less than. All right. Closed circle because the equal portion. Less than, shaded to the left. All right, look at that. Beautiful colors. These ones were a little bit tone deaf right there. Like I had it in the wrong corner, but that's okay. Y is less than 1/2. Open circle at 1/2 and shade it to the left for less. Remember the trick I told you yesterday for graphs? As long as your variable's on the left, you could view these inequalities like little arrows telling you which way to shade, right? So there's an arrow, shade it to the left. That's what I did. Here's an arrow, shade it to the right. That's what I did. If I didn't flip it, I can't trust this arrow anymore. It would have lied to me. You liar. Oh, I knew it. I'm never going to trust you 1/2. Well, okay, here we go. Let's jump right into this. This is going to be, oh man, I'm pumped about this lesson, guys. I think let's just pretend we're like learning this because you guys already know how to do this. You're so good at it. All right, subtraction property of equality. Guess what, friends? You can subtract the same number from each side of an inequality, and it produces an equivalent inequality. So if I have 2 things, I can subtract the same thing from both sides, and it is still related in the same way. Right, same idea here. If I got 2 numbers that are less than each other, let's say, and I take C away, so I move to the left C units, notice that this one is still less than that one. That's the idea. All right, let's just jump right into the example. Question, comment. Yeah. All right. Let's see. I've got, wow. All right, write this one down, friends. This is golden. Good stuff, good stuff. 2 more. We're doing 3 examples today. It'll be good. Let's see, solve the inequality. Guess what? Y plus 8 is less than or equal to 5. I can move it. Subtract 8 from both sides. Over here, 1.4 plus M. The 1.4 is positive. I can subtract 1.4 from both sides. Okay? So I will have Y. The 8's cancel out. The less than or equal to sign stays the same. 5 minus 8 will be -3. Solved it. Infinitely many solutions, and I can tell you every one of them in this short little expression, inequality rather. Let's see, negative 8 minus 1.4, it's becoming more negative. 8 and 1.4, I think 9.4 in the negative direction. The inequality stays the same. I get m. Let's flip it. M, flip the inequality, is greater than negative 9.4. Not too shabby. Let's see. Let's draw some number lines. Oh man, I like my ruler tool here. This is pretty good. You guys can use rulers too if you want for number lines. That's allowed. It's legitimate. But also, your number lines don't have to be perfectly straight, so don't worry. Let's see. So here I'd have 0. Negative 3 is the point of interest. My wife and I have been watching a Person of Interest lately on Netflix. Pretty good. I'm impressed. I like having lots of old seasons to go back to. Let's see. Actually, let's graph this one interesting. Like, let's say I've got negative 10 and negative 9. Let's see. That'd be negative 9.5. Yeah, let's do that. Let's do that. So, y is less than or equal to negative 3. Closed circle, less than left. Good, good. This one, m, is greater than negative 9.4. Negative 9.5 is there. Negative 9.4 would be just to the side of it. And greater than, shade it to the greater side towards the positive numbers, like so. And if I wanted to do a quick check this out. Is 0 a solution? In the graph, it is. Let's check that up here. Is negative 8 less than 1.4 plus 0? Or is negative 8 less than 1.4? In fact, it is. Over here, check this out. This is one of my favorite types of checks. There's this idea of proof by contradiction. Assume the wrong thing is true, and then prove it wrong, thereby showing that what was right was right. Okay, so watch this. I don't think 0 is a solution of this inequality, but 0 still is my favorite number to do a check with. All right, I'm going to try 0 here. 0 is not a solution. If I plug 0 up here, I'm expecting it to not work. 0 plus 8 is 8. Is 8 less than or equal to 5? It isn't, which is what I expected. Therefore, I was correct in the direction that I shaded. All right, you see that move? That's a good move. You also could have tried a check with like negative 4. Negative 4 plus 8 would have been positive 4, which is less than or equal to 5, if you don't like that weird double negative thing. All right, last example. We've got, all right, we had a lot going on today. Ooh, this one's going to have a nice little table for us. All right. Ooh, electricity. All right. Be careful with electricity, friends. You got to respect it. But at the same time, I learned to rewire my entire house by watching YouTube. You can learn Algebra 1 by watching my YouTube videos, and it's far less dangerous for you. Yeah, there we go. So not negative 9.4 was the point of interest. Open circle shaded to the right. All right, cool. And let's see, this one, don't feel like you guys have to like write it all down or anything. Just follow along. Let's see if we can just think through this together. A circuit overloads at 1800 watts. I used to actually want to change my gamer tag to 1.21 gigawatts. Spell watts that way. How classic would that be? That'd be the best gamer tag on Xbox Live. Also, it's a reference to Back to the Future. So let's see, 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. Okay, so they asked this question, right? I want to have a variable that represents how many watts I can add. So I'm going to, for my variable, say x equals number of watts you can add. Okay. Now my equation, which in this case is an inequality, I know that I've already got 1100 watts in there. And I'm going to add x to it. So I could write 1100 plus x, or I like to write it the other way around. Let's do x plus 1100, how about? That seems like a nice equation, or expression. And I know that I cannot go over, well, it says actually overloads at, that means I can't even equal 1800. So I'm going to stay underneath 1800 watts. Okay, stay below 1800 watts. I don't want the equal to part here. It'll be too late. So there's my inequality. Let's see, did they ask us to solve this? No, they just asked, oh, write and solve. Okay, so let's solve this. Solve it. All right, so if I want to figure out how many more watts can I add before I overload it. So let's see, x plus 1100 is less than 1800. What could I do to both sides to get x by itself? Subtract 1100, 1100, or 1100. Those would cancel out. I'll get x. The inequality is still the same, friends, and I get 700 watts. Solved it. I could, if doing this proper, then write a sentence answer saying you can add 700, or sorry, no more than 700 watts. No, I need to say less than. You can add less than 700 watts. Okay, what does part B say? Part B. In addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading it? Okay, can I plug in the toaster? No. Can I plug in the hot plate? No. Can I plug in a blender? Yes. Can I plug in a clock radio? Can I plug in both a clock radio and a blender? Can I take the clock radio that's plugged in and put it into the blender and turn the blender on? It's probably a bad idea. And also, don't place them into the microwave. Like, guys, why are you even coming up with these ideas? I don't understand. You guys are so weird. So yeah, you can add the clock radio. I just wrote kluk. There, I'll turn that O into a C. The clock radio, blender, or both. Right, those are the only things that I can add to the circuit without overloading the circuit. Which, by the way, shaman cards in Hearthstone with overload, that's an interesting mechanic. It allows you to use a card before you have enough mana crystals, right? And it kind of like, you know, is balanced that way. And then they've even got cards that unlock the overload cards. It's pretty amazing. You guys got to go check out some Hearthstone channels out there, my friends. Well, anyways, thanks for learning inequalities with me on the internet. Bye-bye, friends.